Hello, my name is Manoj Verma, and on this channel, I teach the AS and the A level of chemistry. Now, my today's topic is the mole concept, where I'm going to solve some past paper questions on the mole concept. But this particular paper, which you see, is from the Pearson EdXL AS level, but it is the same or very similar to the kinds of questions that you get in the Cambridge Board AS level exam 97001 code. So it would be an additional practice for you to solve these questions. So let's look at the question. Barium chloride reacts with group 1 sulfates M2SO4, and according to this reaction it gives barium sulfate. A solution is made by dissolving 7.98 gram of group 1 sulfate. So this here is 7.98 gram of the sulfate, and it is dissolved in deionized water. Deionized water is simply the pure water, and excess of barium chloride is added to this solution so that we get the precipitate of barium sulfate, which is filtered, dried and weighed. We should add the excess barium chloride so that all of the M2SO4 is able to react and get converted into BaSO4. So the mass of the barium sulfide so obtained was found to be 10.72 gram, and we have to identify the group 1 element. That means this element, whether it is lithium or sodium or potassium, which are in the group 1, the relative atomic masses have been given: barium, sulfur and oxygen. So how do we proceed? Basically you are just using these two formulae, that the number of moles is the mass upon the molar mass. So if you rearrange it, the mass is equal to the number of moles into the molar mass. So if you have to find out the number of moles of barium sulfate, where this is the molar mass and this is the this is the mass. So we'll divide the mass by the molar mass and we'll get the number of moles of barium sulfate, which is 0.045930 mole. At this stage there is no need to round off, we'll round off at the end. Now you have to basically understand that the number of moles of barium sulfate and the number of moles of sulfate are one and the same, because 1 mole of barium sulfate contains 1 mole of sulfate ions. So the number of sulfate, the moles of sulfate ions is also 0.045930 mole, correct? And the MR of sulfate is sulfur and oxygen. If you add from here, you get 96.1. So once again you can get the mass of the sulfate by the number of moles, which is this, multiplied by the molar mass, which is this. So you get the mass of the sulfate, which is 4.4138 gram. So if you subtract the mass of the sulfate from the mass of the group 1 metal, which was 7.98 gram over here, you get the mass of the metal. But the mass of the metal can once again be converted into can be converted into the molar mass by using the formula m upon n. So the molar mass is m divided by n. The mass is this, and the number of moles you know is this. And then if you divide it by 2, because it's M2SO4, you get the molar mass, which is 38.8, which is approximately 39, and that corresponds to potassium from the periodic table. So the M2SO4, in the M2SO4, the unknown element is potassium, and that's the answer. Hope you understood. If not, go through the entire solution once again and try to understand. Then we'll go on to the next question. which is again based on the mole concept. Again, it's a lengthy question carrying 4 marks, so you have to have several steps in it. So let's see how it is done. The half equations for the electrolysis reactions are given. At negative electrode, aluminum is deposited. At the positive electrode, oxygen is liberated. So they are in the ratio of 2:1.5. This oxygen then reacts with the graphite electrode and converts it into carbon dioxide. Calculate the volume of carbon dioxide measured at RTP, which will be produced by 1 kilogram of aluminum using this process, and the molar volume of the gas is 24 tm cube per mole at RTP. So the first step is to convert this 1 kilogram to moles. So 1 kilogram is 1000 gram, and when we convert it into moles, we are going to divide this by its molar mass of aluminum, that is 27, and that gives me 37.037 mole. Now from the mole of aluminum we have to know the mole of oxygen which is formed. So they are in the ratio of 2:1.5, which is equal to 4:3, but the number mole of carbon dioxide formed is equal to the number of moles of oxygen. So it will also give you the same amount of carbon dioxide, that is three parts, right? So now 4 mole of aluminum give you 3 moles of carbon dioxide. So we had how many moles of aluminum that you can see here? We had 37.037 mole of aluminum. So by cross multiplication we can get the moles of carbon dioxide, and when we multiply the moles of carbon dioxide, which is 27.778 by 24, because 1 mole occupies so many dm cube, so we'll get the volume of the carbon dioxide which is formed, which is 667. Here we can round off to 3 SF, and this is the volume of carbon dioxide formed from 1 kilogram of aluminium, as asked over here, when this process is conducted at electrolysis. Hope you understood both the questions, how to solve them. And if not, please go through once again and try to convince yourself that you know how to do that. And uh, if you like the video, and if you like more such videos, please like the video and give your comments and share the video. Thanks a lot.